Hey Venkat, and a big welcome to all your friends tuning in right now. I am absolutely thrilled to be hanging out with you guys today. Consider this your ultimate explainer. This is a high-energy masterclass designed specifically to help you completely ace your 7th standard science exam on heat. I know, exams can feel super overwhelming, but look, as your teacher, I promise you that by the time we wrap up today, you're going to understand this subject inside and out. So grab your notebooks, get comfortable, and let's crush this chapter together. Okay, let's dive into this. Here is our game plan for today. First, heat basics and conduction, then convection currents, sea and land breezes, radiation rules, the thermos flask synthesis, and we'll finish it all off with a rapid-fire final exam recap. Let's get to it. Section 1, Heat Basics and Conduction. All right, first things first, we have to lay the foundation before we get into the tricky stuff. Let's start with your key textbook definitions. What exactly is temperature? Simply put, it's just the degree of hotness or coldness of a body. Pretty straightforward, right? But heat energy is slightly different. Heat is the actual form of energy that flows from a hot body to a cold body. Think of it like water flowing down a hill. It literally only flows one way, hot to cold, until both bodies hit the exact same temperature. Oh, and definitely jot this down for your test. Heat energy is measured in units called calories or joules. Lock those keywords in. Okay, so there are 3 modes of heat transfer. The very first one is conduction. So the crucial point is, you need to memorize this exact definition for your exam. Conduction is the primary mode of heat transfer in solids. It happens when heat is transferred within a single body, or when 2 bodies are physically touching, like indirect contact with each other. Remember, if there's no contact, there's no conduction. To really wrap our heads around conduction, we gotta talk about conductors and insulators. Conductors, like metals, they let heat pass through them super easily. For instance, copper is a way better conductor than stainless steel. That's exactly why those stainless steel cooking vessels in your kitchen at home often have a copper bottom. It just makes the heating so much more efficient. On the flip side, insulators are terrible conductors. We purposefully use heat-resistant plastic for the handles of those pots and pans, so we don't burn our hands. And think about your cozy winter sweaters. We wear woolens because wool has these little series of curls called crimps. These crimps create tiny pockets that actually trap a thin layer of air. And that trapped air, it acts as a brilliant insulator, completely stopping your body heat from escaping into the freezing cold. Section 2, Convection currents. Moving right along, here is your second major definition. Convection is the method by which heat is transferred by the mass movement of the liquid or gas itself. Now, why does this happen? Well, unlike solids, the molecules in liquids and gases aren't packed so tightly. They're free to move around. When a fluid heats up, it actually gets lighter and rises, carrying all that heat energy right up with it. Meanwhile, the colder, heavier fluid at the top falls down to the bottom to take its place. This creates a constant circulating stream. Your textbook has a fantastic activity to visualize this, and I want you to picture it step by step with me. Imagine you fill a glass beaker halfway with clear water. You gently drop a little pinch of potassium permanganate crystals, or even just food coloring, straight to the bottom and let it settle. So the water at the bottom becomes colored, but the top stays totally clear. Then you gently light a candle right under the beaker. Guess what happens? You will literally see columns of colored liquid shooting up in the beaker. The heated water molecules at the bottom get lighter and rise, carrying that colored heat energy all the way to the top. That visual right there, that's convection in action. And this brilliantly illustrates why understanding convection is absolutely essential for designing the homes we live in. Think about it. If you want to warm up a room with a heater, where do you put it? Down low, on the floor. The hot air rises and the whole room warms up evenly. Conversely, an air conditioner is installed way up high because cold air is denser. It falls and cools the room as it sinks. Oh, and this is also exactly why old buildings were built with ventilators near the ceilings. It keeps them cool in the summer because the hot air rises and just escapes right out. Section 3, Sea and Land Breezes. Venkat, listen up. This is a guaranteed exam question area, so give me your absolute focus here. This entire concept relies on one golden rule. Land masses heat up way faster than water bodies, and they also cool down way faster. Let's put the day and night cycles side by side. During the day, the land gets super hot really fast. The warm air sitting above the land rises, and the cooler air hanging over the sea flows right in to take its place. We call this a sea breeze, and it usually kicks up in the afternoon. Now at night, the exact reverse happens. The land cools down incredibly fast, while the sea is still holding on to its warmth. The warm air above the sea rises, and the cooler air from the land rushes out over the water to fill the gap. That is a land breeze. Okay, here is your cheat code for the exam. The breeze is always named after where the cool air is coming from. Cool air from the sea, sea breeze. Cool air from the land breeze. Easy. Section 4, Radiation Rules. All right, here is your definition for the exam. Radiation is a mode of heat transfer that takes place in the form of electromagnetic waves. The biggest game changer here, it does not need a medium to travel through. Heat radiations can travel through air or water, sure, but they can also travel through a complete vacuum. This is exactly how the sun's crazy amount of energy reaches us across the total emptiness of space. Your book actually suggests a really simple activity for this. Just switch on a light bulb and hold your hand a little bit below it. You'll definitely feel the heat. Since we just learned that hot air rises due to convection, the fact that you feel heat below the bulb proves that the energy is reaching your hand via radiation. Now, how objects interact with this radiation depends heavily on their color. Bodies that are black or really dark absorb a ton more radiated heat. Bodies that are white or light-colored, they absorb much less. This is precisely why we wear light-colored clothes in the summer. They absorb less heat and help us stay cool. But in the winter, we wear dark clothes to absorb as much heat from our surroundings as we possibly can. We see this science applied everywhere. Electric room heaters actually have mirrors behind the heating coil to reflect the radiated heat forward, so it doesn't just get wasted. And solar panels? They use black metal sheets to absolutely maximize how much heat they absorb from the sun. Now, what's really interesting here is a specific fact file right out of your textbook. Since all objects radiate heat energy, we humans can use things like infrared photography to see in complete darkness. But guess what? Nature totally beat us to it. Rattlesnakes have these special biological detectors that allow them to literally see in absolute pitch black. How? By detecting the actual heat being radiated off of warm-blooded animals. I mean, come on, that is just the coolest fact in the whole chapter, hands down. And speaking of capturing radiation, your text highlights a really fascinating case study. Because a massive part of India receives a tremendous amount of solar energy almost all year round, it can be captured for heat and even converted directly into electric power. The government of India has actually set up several initiatives around this. These programs are built to encourage small businessmen, industrial setups, and farmers with big areas of land to install solar panels. There are even schemes for everyday citizens to just throw solar panels up on the roof of their house, which helps bring sustainable power to both rural and urban areas alike. Section 5. The Thermos Flask Synthesis. Let's move to and see how this builds. Honestly, this is basically the boss battle of the chapter. This is where all three modes of heat transfer are challenged at the exact same time. Let's see how a brilliant, everyday piece of technology puts all this science together. A thermos flask is specifically designed to minimize heat loss by conduction, convection, and radiation. How does it pull that off? Well, heat loss due to conduction is practically eliminated by using insulating materials, like plastic, in the build. And heat loss due to radiation is shut down by making the inside surface of the jar highly reflective. That way, any heat radiations trying to escape are just bounced right back into the jar. Because the design is actively fighting off all these modes of transfer, a cold liquid sitting inside that flask is going to stay cold for a very, very long time. Section 6, Final Exam Recap. Time to lock this all in. Let's do a rapid-fire summary. First, measuring heat. Thermometers are the go-to device. They generally use liquids like mercury or alcohol, though obviously modern digital thermometers are much more accurate and way easier to read. Second, the three big modes of heat transfer. Conduction is for solids. Remember, substances that conduct easily are conductors, and those that don't are insulators. Convection is for fluids, using mass movement of the molecules. And radiation relies on electromagnetic waves. It's the only one that doesn't even need a medium to travel. All right, Venkat, and everyone studying right along with you, let's test you with the exact Let's Remember questions straight from your book. I want you to shout the answers out loud. Question 1. Which thermometer do you use for boiling water? Alcohol or mercury? Since water boils at a really hot temperature, a mercury thermometer is your best bet, because alcohol boils at a much lower temp. Question 2. Does a land breeze blow in the morning or at night? Nighttime. The land cools faster, and that cooler land air rushes out to sea. Question 3. In the dead of summer, do you wear dark or light clothes? Light-colored clothes for sure, because they absorb way less radiant heat. Venkat, you and your friends absolutely crushed this masterclass. You are officially ready to walk into that exam room with total and complete confidence. But right before you go, I want to leave you with one final, totally mind-bending thought. If you were designing a spacesuit to protect an astronaut from the extreme fiery heat of the sun out in the complete vacuum of space, which of these three modes of heat transfer would be your absolute biggest enemy? And how would you fight it? Think about it. Be sure to share this explainer with your classmates so you guys can debate it and ace this test together. Keep asking great questions, keep studying hard, and I will see you right back here for your next science topic. You've got this. Good luck.